of Medical and Technical Information Technology. And I am going to speak to you today about automatic bioimpedance signal analysis, smoothing versus efficacy evolution in determining the vascular tone type. Vascular tone refers to the degree of blood vessel constriction in relation to its full expanded state. The bioimpedance technique can be used to determine vascular tone type in human lips. This method is considered effective in determining blood vessels tone and many other biomedical issues. There is three types of vascular tone are often encountered: normotonic, hypotonic, and hypertonic. In Figure 1, we see the ideal bioimpedance signal and its basic feature points. C1 is the first systolic wave peak. C2 is the second systolic wave peak. D is a diastolic wave peak. B is a pre-systolic wave peak, and I is the incisor. Type of vascular tone is usually determined by the ratio between two values: dichrotic index (DKE) and diastolic index (DCE). In Figure 2, we see a real bioimpedance signal from the lower part of leg and its basic features points, in which we can determine the dichrotic index and diastolic index C and I and D. And in Figure 3, we can see the areas of vascular tone that detected by DKE and DCE. In circle B, that is the area of hyper tone, and circle A and C is the area of normatonic, and circle D is the area of the hypotonic. Problem statement: when applying an algorithm for automatic signal features point detection, it is necessary to determine the method for signal smoothing. Considering that the algorithm work with recorded signals from separated parts of the body with the same general shape, one method can be adopted for smoothing the original signal. In Figure 4, it's the raw signal obtained by Rio-32 device, Rio-32 device from the upper part and lower part of the leg. In the leg D, the lower part of the leg signal of lower part, we can see that all features points is clear, C and I and D. But in the signal leg up, the upper part, just feature point C is clear. In most cases, the point C is clear, while the point I and D is not clear as the signal in leg up. For the methods, many methods can be used for smoothing signal, but the question is which method I had to use and which criteria determine the best method. In our study, we used three methods that is common in signal processing. It's Savitzky fibulari smoothing and Lewis and binomial smoothing. Figure 5 shows the first stage result of signal smoothing using the three methods. It's clear that we have to reduce the window width for the binomial and Lewis, and we had to increase it for Savitzky fibulari. In the final stage of smoothing using the three methods for one cycle, Figure 5 shows the results, and we can see that the results of smoothing is acceptable in general. But the most important question: which method I have to use in my algorithm? For discuss these results, the obtained results must be tested in order to have a good and effective discussion about them. The table show the average time samples numbers of features point, and this numbers is the symbols and not real time. The value of average C, average I, and average D express the mean time in which features point C, I, and D respectively have been detected in the cycle. And to make it clearer, in the figure, we can see amplitude and samples. In this table, the average C is the average C time for all cycles in our long-term signals. The tested signals have 520 cycles. For detecting error percentage, the second way to find the error in determining time of feature points C, D, and I is by finding the error percentage. To do that, we get a group of 150 cycles has been selected from the signal at separated time. The features points during these 150 cycles has been manually determined, and then the conversion has been made with each of the used methods. The standard method or way which has been adopted is to reject every cycle with error in feature points time greater than 50 symbols or 0.1 second. And based on this method, among the 150 reference cycles for the Savitsky-Golay method, we found 134 cycles. And similarly, 130 cycles has been matched for the binomial and 100 and same cycles for Lewis. From these results, we can say that Savitsky-Golay and binomial is best for our research because we found these 3 points in the larger amount of cycles. But how we can judge which method, Savitsky-Golay or binomial, we have to use in our algorithm. The figure figure 6 shows the error in determining time of features points C, D, and I. And we can see that the less error in time of this features point is by binomial method. So, as a conclusion, in this work, the general shape of bioimpedance signal in human limbs and its main features point, which are used in automatic analysis of the signals, has been presented. Several methods of the signal smoothing has been presented as an essential step in signal processing and analysis. According to the obtained results, choice of the methods and its coefficients depends on the study purpose. As an example, Savitsky-Golay method can be used if analysis versus mainly depends on the feature point C, and the binomial smoothing gives more accurate results in the feature point time for C and I and D, and as a result for type of vascular tone. Thanks for your attention.
Thank you very much. Anton, maybe questions from you? Oh, yeah.
I'm ready for your questions.
Well, my question will be maybe sound strange, but is the smoothing the only way to find these feature points, or there can be some completely different approaches for this task?
Yes, there is another way for find this points. We have 3 ways. First, manually, and that is gives the best result, but because the doctor or scientist he can see it. And second, by algorithm, as our work, and third way is by machine learning. But for machine learning, that is we must have a very big database to do that.
Okay. In MATLAB language and in SciP module in Python, you can find function peak detect CVT. This function uses wavelet smoothing for local window and detect peak and with these windows. Do you try to compare your methods and Savitsky Glide and others with this function, because it's most usable function for this task?
As a basic, I use Python, and in SP, yes, there is Savitsky Glide as standard, and I write the binomial method. Our purpose of study, the objective purpose, is how I can compare that results, and by using the smoothing methods in CP, Python, and binomial. The purpose was to find the error percentage in time, and after that I chose binomial, but I tried smoothing methods in Python SP.
Okay, I talk not about smoothing, but not Bayesian smoothing, but about wavelet smoothing. Okay, I copy name of this function in chat. Maybe it help you in further studies. And for my point of view, for this studies, it's very important to compare your approach with some baseline approach which is widely used in this field. Okay, in any case, thank you for presentation. It's good work, and we go to the next. Do you have any questions, my friends? No questions. Okay. Maybe some questions on YouTube, because I don't check it about those about half hour. Okay, the next presentation is Hanadis Soliman. Investigation of the transformation methods accuracy of 12 leads ECG to orthogonal leads using multiple error evaluation metrics. Okay, interesting topics. Let's start, please.
Hello, everyone. My name is Hanadi Sulaiman. I was earlier in the first section. So my study is about investigation of the transformation method accuracy of a 12-lead ECG to orthogonal leads using multiple error evaluation methods. You can hear me?
Yes.
Okay, great. Okay. So, what is the relevance of our work? First of all, we know that the cardiovascular diseases are the leading cause of mortality globally. So while using VLB, we are able to diagnose these disorders. To detect or determine the VLB signals, we can estimate them using the heart vector magnitude. This heart vector magnitude is not obtained clinically, but we can calculate it from orthogonal leads. The orthogonal leads are not anymore used in clinical detection. They are not registered most of the time. So we need to transform the 12-lead ECG to orthogonal lead. So our objective is to investigate the appropriate metrics for the error